We will get started at 10:05, same as always. So somehow there's a setting I needed to change, and I think I changed it, but who knows if I actually did. So again, just let me know if things go terribly, terribly wrong. Good morning. Welcome to another session of Practical AI. Let me share my wonderful PowerPoint. So today we are talking about my favorite thing, which is AI models that aren't large language models. Because usually when we think about AI, or the reason why everyone loves AI, is because that we have a chatbot. You know, we talk to ChatGPT, and that is the reason why everyone loves AI and everyone knows AI. But as we've seen, we end up depending upon these, corporations out there that charge us money for API keys or don't come to our country. We have to, give them money in order to do this processing, blah, 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 blah. So hopefully today, and also the next session on local models on next Tuesday, we will start to look at how we can kind of break away from our terrible overlords and do things a little bit more on our own terms. So today's big plan. Number one, the one big problem with large language models. We're going to talk about what the word model actually means. I've been using it a lot because it's the technical term of what we're using. But do we really know what they are? Then we're going to talk about a few different kinds of models, text models, image models. We're going to try some out in a few different ways, both on like a fun little click around internet style, in Google Sheets, in Python. And then we're going to be doing some fun bonus tricks. We're going to make a chatbot which can read documents that we have and answer questions about them. Now, I'm not 100% sold on this order here. So if you like, we can bounce around a whole lot. We can write code during it. We can go to Sheets during it if you want to see demos in other different ways. But we're going to see what happens. As always, when you have questions, throw them in the chat and we'll see what happens. So, models. We are starting by talking about what models are. And to get there, we have to kind of talk about the problem with ChatGPT. And so the problem with ChatGPT is that it can do anything. It can do anything. It is like, has anyone had a Swiss Army knife that has, this is probably 200 different things that it can do? Can it do any of those things well? Potentially, but also what are any of those for? Like, what's the little guy with the circle for? Why are there 600 knives? Like, they're all clearly for specific tasks, but what are they really? When we're dealing with a AI tool like a chatbot, it has poor discoverability. It can do a ton of stuff, but you don't necessarily know what that stuff is. Like, for example, in the very first section and in the second section, we just put things in categories and we extracted some data from pieces of text. They're all for cutting. Yes. Some of them are for poking. I think this one, I don't know if you can see my mouse. Yeah, that one up there might be for poking and not for cutting. But yes, everything else just for cutting. So when we're dealing with these tools, we don't know what they can do until someone shows up and says, hey, did you know you could pull all of the names out of a document and do this, or put documents in categories using a chatbot? And you're like, oh, thank you for telling me that. I had no idea. A lot of folks, when they first sit down with a large language model, are just like, I have no idea what kind of conversation to have. And you just say, how was your day, chatbot? And it says, my day is great. What can I do for you? So when we're talking today, we're not really, yes, there is the Allen wrench, which is not for cutting or for poking, but rather for turning. So when we're talking about stuff today, it's very rarely going to be about specific tools. It is about kind of more the idea of tools or the genre of tools instead. And there are two reasons for this. I could show up and say, here is exactly what you're going to be doing. And no, because we want freedom. We want flexibility. Everyone has a slightly different use case. And so in the same way that some people might prefer Claude, whereas other people prefer ChatGPT, we are also going to be saying, hey, it's all just chatbot. It's all just text classifiers. It's all just whatever. It's about being able to adapt to your use case. And I also, here, let me hide myself so you can see my frowny face much better. So I don't like vendor lock-in. I don't like the idea that we have to get married to OpenAI or we have to get married to Anthropic in order to make any of these things happen. So the goal today is to kind of say you don't need to be subservient. I mean, some of these tools, yes, they do come from Facebook or they do come from Google or whatever, but we don't have to have a long-standing relationship with them in order to make this stuff happen. So when we talk about tools, I'm going to use the word tools, but what we really should be saying is models instead. Models, 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 models. No more saying tools, except for the fact that I will probably say tools 200 or 300 more times. A model, it's if you're a math person or a CS person or an environment person or an architect or someone who likes to build train sets in your basement, a model is just a simplified version of something that is real and out there in the world. In the same way that if you have a model home, actually a model home is a real home that you can go into to kind of see. But if you have like a model train, say, or a model car, those are much smaller versions that you can like hold in your hand, where you've given up some of the flexibility of a real car so that you can actually have a car that fits inside of your hand. In our case, a model is something, and you're going to have to believe me here, it's something that you give an input to and you get an output out of it. If you're familiar with models for real, you might be like, this is a fantastic explanation, or you might be like, this is the worst explanation that I've ever heard. But models, in the same way that like, what is a tool? What can a tool do? A tool can do literally anything. And in the same way, a model can do literally everything. So, for example, most of the time when we're dealing with this AI stuff, we are dealing with a chat model. And what a chat model does is a chat model takes some sort of prompt or something that you type in, and what do you get back from it? You get back some sort of response. Like this is not rocket science. It seems kind of silly that it has to be stated like this, but that's what a model is. That's what a chat model is. It goes back and forth. You give it some sort of text, it gives you some sort of text back. Now, I don't know why I have another slide that shows it to you like this, but that's fine. There you go. Can it count the number of N's in mayonnaise? Sometimes it can, sometimes it can't. So first class, second class, we extracted data. And one of the things that we did was we said, we have all of these bills that are in the Louisiana state legislature, and we want to put them into categories. So the categories are like education or retirement or crime in all caps, or whatever you might, category you might put a bill into. And so this is actually a kind of model where you take the bill text, you feed it into the model, and then you get a category out of the other side. And it turns out that this kind of thing actually has a name. So in the same way that a chatbot is a chat model where you give it a prompt and it gives you a response, this is a text classification model. And so why is it called a text classification model instead of like a text categorization model or something like that? Who knows? It's just what it is. You're just gonna have to live with it. The classical name for this is a text classification model. And basically all we're gonna be doing today is finding out the names of the things that we want to do so that we can either do them with a large language model or do it without a large language model. So if we go back in time to the infinitely in the historic past of 2019. We talked about this piece probably 2 or 3 of the past sessions where the Washington Post had 130,000 app reviews pulled from the App Store, and they had to filter them to say, is this about unwanted sexual behavior or is it not? And so what they did was they made a text classification model in order to do that. This was pre-LLMs. They had to do this by hand in the old-fashioned way. And I love this, and I've said this before, because they have a video which literally has a picture of the spreadsheet that they were using, where it's like, look at this. Here's where I marked. This review is about unwanted sexual behavior. This review is about bullying. So they had to go through a subset of them and say, hey, these ones are about unwanted sexual behavior. These ones are not about unwanted sexual behavior. Unlike what we had to do the other day, where all we did was say, hey, large language model, put these in categories. You know what crime is. You know what education is. You know what retirement is. I'm sure you can figure it out. Historically, you weren't able to do that. It was like a horrifying, complicated situation. I made this giant website called investigate.ai where I basically tried to teach data science in a very practical sense to journalists. So sort of the same thing that we're doing here, but it was so much more technical out of necessity. Like the programming was very, very intense. Yeah, logistic regression, TF-IDF. So you had to choose like the way that you would adjust for frequency of words. Like if every single review has the word monkey in it, because that's the name of the app, do you say, oh, the word monkey is less important than a word that shows up more frequently? If you have the word fish, is that the same word as fishes or fishing or fished or things like that? And so you had to make like a million decisions all the time. And it was a horrible situation. It was a horrible, horrible, no good, very bad situation that really prevented a lot of people from using these tools that were very, very effective. And so you can still do things this way, but wouldn't usually recommend it. It's kind of more like if you needed to classify a bunch of documents. If you went back to, let's say 2019, it's like you have babies. You have a bunch of little babies that don't know anything. They were just freshly birthed into this world. And you say, babies, can you read these documents for me and sort them into different categories? And the babies say, I don't know how to do anything. I don't know how to read. I don't know what words are. I know literally nothing. And so you had to build it up from scratch and say, okay, this is a word. This is a part of a word. This is a verb. Here's how you can like stem a verb. Here's how you can make things not plural. Here's how you can adjust for frequency. Like you just had to do everything with this baby. And just like raising a normal child, you can do all sorts of things wrong. And even if you do everything right, you can still get garbage results at the end, even though you've invested so much time and effort into this little tiny baby. So nowadays, we live in a slightly nicer world where instead of these dumb little babies, we have a grouchy teenager. And so there are a few different ways that we have a grouchy teenager. Either we have an LLM where you're like, hey, can you do this for me? And like, maybe it's lazy, maybe it's biased, maybe it's just like, I don't want to do that. It doesn't sound like something that would be fun for me. On the other hand, we have what we're mostly going to be working with today is models that aren't necessarily as smart as LLMs, but they only do one thing and they do it pretty specifically. And maybe you can tweak them to get better at it in a way that would be maybe cost prohibitive or tech prohibitive from a large language model. So historically, 2019, we had little babies that we had to train. These days, we have teenagers that think they know everything and maybe act sassy to us. But right now, we're kind of models that are pre-GPT, but also post-GPT we're going to be working with that you'll see. It'll be great. It'll be great. But again, the problem that we've had is we don't know all the stuff that a large language model can do. We know that it's large. We know that it works with language, and we know that it is a model. And beyond that, you just say like, you say, what's the news today? I saw someone was tweeting earlier today about how they did, I guess it was a study about if you ask the large language model for the most top 5 headlines of the day, maybe it was like top 5 headlines of certain news orgs. Most of them are like, I can't do that. I can't access the internet. But some would just gladly make up headlines. And I didn't actually read the piece. But like, you don't know if it can or can't do that until someone says like, hey, you idiot, it can't access the internet, don't do it. Or someone tells you, hey, it can access the internet. Last class, we asked it for the average weight of an adult male capybara. And it's like, does it actually know that? Or is it just making things up? Who knows? So like, what is it capable of doing? Can you convince it to do better? I don't know. Read like a giant book called ChatGPT Prompt Engineering for Developers and potentially get better at it. Again, poor discoverability, awful world. But, if you know the words to describe the task that you want to do, either A, you're going to find out how to do it easily with a large language model, or B, you're going to be able to find another model, which is mostly what we're talking about today, to accomplish the task. So the goal today is really just a vocabulary lesson. It's to kind of think through what all of our opportunities are when it comes to kind of automatically processing text and images and video and audio. Because honestly, anything that you want to do, you're not the first person who has done it. And oftentimes when you are working on a project and you think, if only like, oh, I have all of these videos. If only there was some way I could take all of the text out of it or take all of the audio out of it and then turn it into text. And then I could just read what happened in the videos instead of watching it for hours and hours, like a podcast, right? Like I'm always angry. I hate podcasts. Like the daily, how slow can they talk? I just want to read something. Just give me like 4 paragraphs. It'll be great. I can do that in 10 seconds as opposed to listening to a 40-minute podcast. But unless I know that there is something called transcription or audio extraction or something like that, I'm not going to be able to necessarily, Google my way to success there. So basically all we're going to do today is track down words like text classification model so that we can classify text, or even potentially zero-shot text classification model, which is a subset of a text classification model. Yeah, listen to the daily at 1.4x as a rule. Yeah, it's totally relevant. It's 100% relevant because I think so much of what all of these tools are good for is preventing you from wasting your time. And I often think that listening to the daily at 1x is absolutely a waste of my time, where if I could listen to it at 1.5 or 2 or 3x or 5x, I'd probably still be able to understand what's happening and I would be happy. But yes, reading a transcript also much faster. So last session, 2 sessions ago, we talked about this kind of situation where I was trying to say, hey, I have a sentence and I want to pull some stuff out of it, right? So I want to say, hi, I'm Jonathan Soma giving this talk at this conference in Sao Paulo. Please pull out locations or events or people. And if I know that this is called a named entity recognition model, so easy, so great. Like I can just take the document, I plug it into my NER model and I get the entities back and it's perfect. / I know that I can type some text like this that says, hey, ChatGPT, list the named entities in it below. But if I'm just like, I want to get people's names out of it, and you just Google like use Python to take names out of a text, it's incredible because Google does that thing where up at the top they make suggestions about, hey, we automatically generated some code for you. And the code they gave me was like a list of names that were all like John, Paul, Mary, Deborah. And then they just try to extract those specific names out of a piece of Python text. And it was awful. It was terrible. And so if I'm just trying to say use Python to take names out of text, it's going to be a failure. But if I know Python named entity recognition, suddenly my world has been opened and everything becomes perfect and delightful. So let's do this. Here are all the different things you can do. Here, not even all of the things you can do. So if we wanted to talk about the different models that are available to us in the world, this is a pretty decent list. Is there anything in particular that people would like to talk about today that is on this gigantic list that I pulled from the internet? Because my next slide is I'm highlighting all the ones I'm talking about, but if there's anything that we want to talk about specifically, I can pump it up in my list. Here's what we're talking about. Video classification. Video classification we're definitely not doing today. Text to speech. You all are all about the audio video. I think the very last session, we're going to be doing more of the audio video stuff. I think that for video classification, my argument is you should probably just chop it up into a bunch of frames and classify them individually. But thank you, Federico. We are doing classification models. We're going to start off with that one there. Let's see. Speech to text. Speech to text is on here. It is audio to text. Oh, I didn't highlight it. Where is it? Somewhere on here. Anyway, we're going to do a bunch of this stuff. It's going to be great. We're going to have a good time. I hate topic modeling. So the way that you do this, the way that you learn all of these things is through a website that is called Hugging Face. Adorable name. Startup of 3 guys from France who moved to New York and then founded it, but they're a delight. And Hugging Face is, if you know GitHub, which is the place where everyone throws their code on the internet, Hugging Face is the place where every model lives. Every time someone releases a new model or wants to play with a model or even has a data set, they just throw all of it onto Hugging Face. So if there is some sort of a stuff that you are interested in and you're like, oh, I want to know about video classification. Here, let's do this now. I don't even know what the next slide is. Let's find out. Oh, sorry. Pretend that you didn't see that if you saw it. If we think about how many models there are, right? When we saw this slide before, you're like, okay, how many different things can models do? A pretty good number of things. But how many models are there overall? And the answer is a zillion models. This is not all of the models that exist in the world, and many of these models are like broken and bad, but it's just anything that you can make a computer do in an automatic fashion probably lives somewhere on Hugging Face. So if you get to a point where you say, I really hope that someone has done something about video classification or text-to-speech or whatever, you can just go on Hugging Face and poke around. Okay, so I'm now going to move to poking around on Hugging Face. Let's see. Screen share. There we go. Okay. OCR. OCR is a big one that is actually not part of anything I was ever planning on talking about in any of these sessions, but maybe we can do that in the final session because that'd probably be a good idea. So if you want to go hang out on this webpage, I'm going to throw it in the chat. This is all of the models that exist on Hugging Face, and you can just browse it. So we're not talking about video classification today, which makes it a really good example of what we're gonna do. Is there time? Could I talk about how Hugging Face came to be? I have no idea. I have literally no idea. I just assumed they were like, it'd be a good idea to have a website where everyone puts their models. Because in the same way, so GitHub is a place where people put their code. And let me see, I'm going to pull up an example of me on GitHub. Let's see. So I have some code right here, which scrapes some stuff. It goes to El País and it scrapes some headlines from it. And you can just go on this webpage and you can see all of my code. You can see all my code, you see what it does, whatever. The problem with GitHub is it's very focused on text. It is a place for like Python. It is a place for JavaScript. It's just a programming place. But it's not for really, really big files. And most models are really, really big. They're either hundreds of megabytes or multiple gigs or dozens of gigabytes, depending. And so it just wasn't a good place for you to put models. So then I guess they were just like, this is a great place for us to throw all this stuff. But I like the idea of it's YouTube for models. But yes. So is a model like code plus parameters plus weights? I'm going to lean back on it's kind of tough because models need to be interpreted by a thing. We'll get there. When we start talking about transformers, we'll get there. Are we going to build a model, even a bad one in Google Sheets? No, but we're going to talk about how to use all of these models in Google Sheets, which is just as good. So let's say you all are interested in video classification. I know nothing about video classification. So what we're going to do is we're going to go down here on the left-hand side and we're just going to click video classification. And it gives us all of these options, Microsoft XClip Large Patch 14. Who likes Microsoft XClip Large Patch 14? Does that sound better than Facebook Timesformer Base Fine-Tuned K600? You're like, I don't know the answer to this. I don't know which one we should be looking at, right? So just like when you go on YouTube or you're reading science papers or whatever, there's certain ways to know what's better. And the best way to know what's better is what's most popular. If something is popular, it's probably good. And so by default, it sorts by trending over here, but I like to go over here and sort by most downloads. Because like the thing with the most downloads might be a little bit older, but I'm sure it's fine. So right now we have Microsoft XClip base patch 32, and just they all have awful names like this, and it's only once we start to get the text models that the names start to get a little more fun. But let's click it and see what's in here. It's been downloaded 178,000 times. We also might sort by most likes to see which one has the most likes. This one has 51 likes, which doesn't seem like that many, but probably video classification is kind of rare. So we'll go in here. So we're in here, and this is what's called the model card. It is the description of the model. And the XClip is a minimal extension of clip for general video language understanding. The model is trained in a contrastive way on video text pairs, and then it shows us this picture. And the number one thing I want you to avoid when you're on Hugging Face is looking at any of this. Any of the stuff on the left-hand side here is a bad situation to be in. Usually there's like a little snippet of code that might explain how to use it, but like oftentimes there is not, and then you're just very sad. So if you want to use the code, there's 100 ways to use this model. The ways to use this model, up in the top right-hand corner here. The two ways we're going to talk about it today are if we click deploy. Oh, this one's not going to work here because this is a fancy model. Can we click this? Yeah. Ignore that. If we click use in transformers, what this is Hugging Face, all these people had these different models that were set up different ways. So to Jeff's question of like, is a model code plus parameters plus weights, what's the equivalent of the .py file of just like the Python code? And the issue was that when people had models, you always had to use them different ways. If you had an image that you, like an image classifier, for example, something where you give it an image and it says, this is a dog, or this is a cat, or this is a hot dog, or whatever, you used to have to give it a very specifically formatted image. Maybe it had to be a certain shape, or maybe it had to specifically be a JPEG file and not a PNG. Or maybe you had to like open up the PNG and make sure there was, I don't know, maybe you had a PNG that couldn't have transparency or could have, like, it was just super, super specific. And so what Hugging Face has tried to do is make it so you don't have to care what a model is. To you, a model is just a thing. It's just some thing where you write this code right here. You say, hey, I'm going to import this thing called the pipeline. I want to make a video classifier, and I want you to go get this model. And so, yes, if you know things about language models or AI, transformers here is not the same as like transformers architecture. It's just the name of a library, just the name of a Python tool that you get to use. And we'll dig a little bit more into it later, but it's just something that you install and then you say, hey, I want to do a video classifier. I want to do a text classifier. I want to do an image classifier, whatever it is. And you're going to use your particular model. Because in the same way that there is Claude and there's ChatGPT, and so two different chatbots that exist, if we want to do video classification, there are also different video classification models. And so that one, let's see, we'll go to video may base fine-tuned kinetics. Sure, why not? And you look through here and it's like, here's how you use it. And you're like, I don't want to type all of that code. This is very confusing. What's a tensor? What's no grad? What's a argmax? They're good things to eventually learn how to do, but right now doesn't matter. But if you scroll up and you click use in transformers, again, this is the simplified code where Hugging Face has made a tool where you can basically ignore everything about how the model works or what the model wants. And you just use this nice little code that says, I want to classify a video. Here is the model that I want to use to classify the video. So let's just pop over. If you hang out on this page, okay, another question from the chat. And even though we're focused on non-large language models, the Hugging Face Transformers library can also provide access to LLMs. Yes, this one here. It does text generation. Yes. The other question is, should we conclude that the Transformers Python package is the entry to Hugging Face models? Yes. So basically what class is today, is how to use, when we get to the Python part, is how to use Python plus the transformers library to do all of this stuff. Oh, also one more thing. Let's see, video classification, sort by downloads, this guy here. If we want to see how this works, or if we want to know that we have the best, there's a few different ways that this might happen. Down here, there's something called evaluation results. And if you click it, it takes you to a website, not found. It takes you to a website called Papers with Code. And Papers with Code is a website that will kind of somewhat tell you what's state of the art or cutting edge for a specific task. So if I click browse state of the art, it's like, which of these 1,773 computer vision tasks are you interested in? Semantic segmentation, tumor segmentation, panoptic segmentation. And so there are a ton of different vocabulary words that maybe you'll end up needing to know, but we're just going to go over some basic ones today. Will says, any advantage to using the transformer library versus Ollama? Transformer, if we're using language models, like use whatever you're comfortable with. I'm going to use LM Studio in the next session. So it's not even a Python library. We just use the OpenAI wrapper. So the only reason why you would use the transformer library is because it's just very easy to work with literally anything that is in the AI world. So if I'm on this page, you're like, I don't know if this is going to work for me. And I haven't actually tried to do this yet, so we're going to find out. Error. Oh no. Are all of these going to have errors? Error. All right. Forget I said anything. Let's back up to the models page. The very first thing that I want us to do is text classification. Text classification the same way we did in session 1, where we said, I have a piece of legislation. So like we did right here, or I have an article. I have an article and I want to put it into some kind of category, put it into a category for me. Now, you might think to yourself, I want to do, I'm going to scroll down here. I want to do text classification. And I'm going to say, no, you don't want to do text classification. What we really want is zero-shot classification. If we go back in time and back in time, go back in time to 2019. And we're working for the Washington Post and we're saying, oh, I'm tagging all of these with unwanted sexual behavior and I'm tagging all of these with not about unwanted sexual behavior. This is how text classification used to work. You had to say, I am going to teach you from scratch what a comment that's about unwanted sexual behavior is like and what one that is not about unwanted sexual behavior is like. And so my question to you is like, if you have a teenager, do we think a teenager has a reasonable idea of what a creepy man or a comment about a man being creepy is versus a comment that's not about a man being creepy? And so when you ask yourself this question, can you make an assumption that something that has read a little bit of the internet knows the difference between these two things? You can do what is called zero-shot classification, where what zero-shot classification is it says, I'm not going to teach you anything. I'm just going to trust that you know the difference between these two things. So I'm going to throw the link into chat for this specific model. Yeah, today's teenagers do. Depends on the state they're from. So if you're here, we're not going to do that sheet yet. I'll share the sheet later. So if we're right here, we said, I'm interested in zero-shot classification. I'm interested in you putting text in a category without me teaching you anything. And so the way that it works is, the greatest thing about Hugging Face is, along with it being a place where models exist, it is a place where you can try them out. So you do not have to be technically savvy to use this website. All you need to be able to do is go to the models page, click. You might have to understand technically savvy enough to understand one of these categories over here. We are trying to classify text without teaching the model anything first. So we want one of these delightful teenagers. Click zero shot classification. We want the one with the most downloads, BART, large, MNLI. On the right-hand side, it says, hey, do you want to try this out? So if you are a Python developer or any sort of developer, you might be familiar with the task of installing things, attempting to get them to work, having it not work, and spending like days trying to wrangle stuff to see whether it's going to work for your use case or not. For Hugging Face, for many of these models, just have a little demo on the right-hand side. So if, for example, we are running I don't know what this is, like you're trying to see whether comments that come in to your service desk are urgent or not. And you say, here is the piece of text, and here are the possible categories that this might go into. Because we're being computer scientists and we're talking about classification, not categorization, we call them classes. And you just say, hey, what is this? And it says, this is about a phone. It's also urgent, but it's mostly about a phone. If I allow multiple classes, it says it's very much urgent. It's very much about a phone. It's not about a computer though. So if I say, let's see, I was cooking breakfast and I burned the eggs and the pan is ruined and I'm so unhappy. I think someone brought up sentiment analysis in the chat earlier. Maybe I got an email about that. I could just be like, is this happy or is this sad? And then I say, compute it, and it says this one is sad. And so it just straight up has a beautiful, perfect demo there for you to use without doing any sort of effort. And so, yeah, Sharon's question, zero shot will work for when you want multiple labels on text. Yes, so all classification models can work in two different ways for classification. Actually, if we go back to session one, let's go back to session one links. I think we did this for one of these. Did we do it here? Nope. This one? Okay, so one of the things that we did last time is we said, hey, is this about retirement? Or hey, is this about employment? Versus just saying, here's one category. The category is education, the category is retirement, the category is crime. So these are two different ways to approaching the classification problem. This one right here, technically speaking, is called a multi-label classification problem, where it can be about retirement and employment. Yes, it can be about both of them. Whereas you can also have a single label where you say, just tell me which of these categories it is about, period. I'm logged into my Hugging Face account, correct? Yes. So can you not do this if you're not logged in? Log in, it's free. Doesn't cost you any money to try these things out. So right here, I'm able to come up with a few different classes and some text. And because it knows what happiness and sadness is, it just does it for me and life works great. Now, if you want to know a little bit more about how this works, or you want to kind of experiment a little bit more outside of this little demo here, if you scroll down on the right, there is something called Hugging Face Spaces. And instead of this thing right here, which is kind of a limited view of how this model works, you can also find these big demos that people have made. So we go here, right here we upload text, it generates keywords, it generates a summary, and then it puts possible topic labels, and then we can ignore this part. So like this is a giant tool that can do all of these things for us. This one right here, this basically looks the same as what we had before. Wow, one day I will see the world. You have examples. One day I will see the world. Travel, live, die, or future. That's horrifying. But basically anyone can make their tiny little web app website here to let you demo this stuff up. I can give out a tutorial on how to build these. I think it's pretty useful for if you're doing things internal to a newsroom to be able to build out a demo, because the technical people are often not the same as the subject matter experts. So for something like this, like I could send this link to someone in my newsroom and say, hey, try some of your pieces of text here and then try the different categories it might be in, and we can see whether the categories actually work. Because maybe, so for example, let me open up my long list of links. Let's see, we are talking about text classification. Okay, so Washington Post. If we do look at this story, when you go through, yeah, they all really want nudes and are creeps. It's nothing but men looking to hook up. I have been swamped with pervs who wanted nudes. Perverts and predators, girls stay away. We can probably assume the model is going to be pretty good at identifying yes or no, whether a comment is about dudes being creepy or not. But not all of the time. Not all the time. So let's say we're talking about this piece that we've previously discussed from the city. Or what the city did was they took about 4,200 stories, and then they put it into ChatGPT and said, ChatGPT, what neighborhood in New York City is this about? And so in theory, we could take a whole story from the city and we could put it in this box and we could list all like 100 neighborhoods in New York City and say, predict which neighborhood this is about. I'm going to go out on a limb here and say it's probably not going to do a very good job. These models haven't read as much content. I like to think of them as, instead of large language models, as medium language models. I don't know if there's like an actual cutoff for like large, medium, small, like what these things actually are. But in my heart and mind, I think of these as medium language models. And so they don't know as much stuff. And so I could try pasting it in here and say, try to put it in one of these 100 categories. It's probably not going to work. So zero shot classification is not always going to work. Now, if we want to use it, ourselves, if we go to deploy, we have talked about APIs before, right? So APIs are the way that we have previously talked to Claude. They're the way that we previously talked to ChatGPT. They're just ways that two computers talk to each other. So if we click Inference API, it gives us some Python code. It gives us some JavaScript code. And I say, do you want to use this Python code? And you say, no, I don't want to use this Python code because previously you clicked transformers and that code looks like less code. This is 2 lines of code. This is more than 2 lines of code. So I'm going to go for the one that's 2 lines of code. But just to kind of show you a demo of what we'll be able to do much later, there is a JavaScript version of the code here where all we're doing is we're going to like a specific URL on the Hugging Face website. And we're saying, what is this XXXXX here? And you look up at the top and it says show API token. And we remember API tokens. API tokens are the way that we prove who we are to a website. So when I use the Claude API or when I use the ChatGPT API or the GPT API, I'm saying, here's who I am, maybe charge me money, right? So in this case, Hugging Face isn't going to charge you money. You can actually use it for free. And because all this is doing is running a little bit of JavaScript code and like going and accessing a URL and pulling it back, something that's kind of fun is if you are in a Google Sheet, you can actually create, instead of relying on there being like a Facebook BART large MNLI extension, you can actually create your own formulas. So previously we did something like equals Claude extract, or we did whatever here. But what if we lived in a world where I could say, hey, I want you to categorize this text based on these potential categories. In the same way that when I go on this website, I can say, here's my text and here's my categories. Because apparently, all you have to do, according to this, is tell the computer to go to this URL and get the responses back. Now, I figured out how to do this last week. I didn't even know it was possible before. I had never thought of it. I'm just going to show you how I do it. If you go to extensions, you can go to app script. App script is your ability to write code yourself and have it kind of create your own custom formulas. It loads, it loads, it loads, it loads, it loads. Let me find my code. Where'd I put my code? Let's see. And let me tell you, this is not very well documented. There's like it's like a 30-second YouTube video that shows you how to do this. And then there's like a link to GitHub where someone just wrote some code and never talked about it again. So no one talks about this, but check it out. So this is my code right here. It basically is the same thing as what showed up here, where I say, hey, here's my secret code. Here's the model that I want you to look at. Send it some, what's even on here? Here's the text I want you to classify. And here's the different labels, refund, legal, FAQ, whatever. And so I just say, hey, I don't know. This is how you write a extra function or a formula in AppScript. How does it work? I don't know. It's just how it works. So saving it. And now I just go back here and I say, hey, I want to categorize this text based on these potential categories. And there we go. And the thing that's so amazing is it doesn't just know about history and sewing. If I have one of my categories as people who bark, human beings who bark, and my text is a guy named Sam who goes woof, 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 it knows that that is people who bark. And you say, how does it know that? And I say, look, I don't claim to actually know how this works. I could say something about text embeddings, but I don't even know if that's the case. It just works. And is this the jankiest possible way of doing it? Yes. Should this be caching results? Should this like be storing my very secret API key here in a way that you can't see it? Yes. So don't steal it. I'll probably deactivate it after class. Yes, I will actually send all of my app scripts functions afterwards. But I guess, yeah, sure. For now, why not? I can throw it in the chat. But I'll put XXXXX here. You'll have to make your own key. Ugh, it's too long. I can't put it in the chat. I'm sorry. I'll email it out afterwards. So it's amazing. And the thing that is fun about this is when you're working with these models, there are so many. So GPT is almost always going to perform better, but GPT is slower and it costs money and you're not in control of it because it might change over time. Whereas something like this, it ends up, I mean, you can download it to your computer or other things like that. You're a little bit more in control of it. And so if you wanted to switch to a different model, because you know, it turns out that this model, even though it's popular, it's not the best one for you, you can just go through all of these. Like, let's say you need a multilingual model. Right now, I think if we look at this model, yeah, it's like only good at doing English, I believe. If you want a model that works in different languages, oh, look, this one right here. Let's see, what's multilingual? This one right here, it's multilingual. It says multilingual, it does different languages. Is it good at the language you want it to do? I don't know. Maybe it is, maybe it isn't. Let's, you know, while we're at this, let's just do a little Python code. We've gone pretty deep in this. I'll show you how it works with transformers. So if you're a JavaScript person and you run JavaScript for your analysis code, like go wild with these endpoints here. I don't know how that works though. I'm going to click using transformers and just like steal this simple code here. Although this code right here doesn't actually tell you how to do it. What I recommend doing is if you go to read docs on a high level pipeline or read model documentation, the model documentation looks like this. Is this something you can understand? No, it's awful. Terrible documentation. Is this something you can understand? Sometimes. The documentation I really recommend reading is the documentation right here. huggingface.co/tasks. It lists all the different tasks that you might want to do in the same way that when we were looking at the models page, we saw all these different options over here, but it walks you through what the models might do or what it might mean. So right now we're doing zero shot. Do they have their, here we go. Zero shot classification is what we're doing. So we're putting things in categories and we're not, doing any training ourselves. We click it and it says, here's what it is. Simple explanation. It gives you a little bit of text that's not too topical or not too complicated. And then it just says, here's how you do it. Start to finish. Start to finish, here's how you do it. So let's steal this code and run it ourselves. Let's see, move to new window, move this here. Okay, the one issue you'll come across with a lot of these things is you need to install a lot of stuff on your computer, but you're fine. I have faith you can do it. So all I'm gonna do is copy all of this and paste it. I'm gonna move this into something called labels. And I'm going to shift enter. And it's going to run it. It runs, it runs, it runs, it runs. It runs, it runs, it runs, it runs. It runs, it runs, it runs, it runs. Now, why did that take so long? Sometimes it takes so long because it's like setting itself up. The problem with you doing this right now is, it's not going to let me put this code in chat. I'll give you all this code later. Don't worry. I'll also give you this URL. You can copy and paste it from there. So when you run this code, it downloads the model to your computer, which is very different from when we're dealing with something like ChatGPT or Claude. When we were dealing with ChatGPT or Claude, one of the problems was they might change how the model works. So if we had a workflow that used to go fine, they might update the model and make it lazy, or they might make the model, do something or some other thing. But we don't have that problem now. BART large MNLI is fixed. It is just a big file that exists on the internet. We can actually go look at it. Let's see. Where'd the model go? Model zero shot. Files and versions. It's just right here. It's just a big file. Look at that. That 2 gigs, 1.6 gigs. They're just several different versions of the model. And so when we run this code, it just downloads 1.6 gigs to our computer and then runs the model. And then we don't have to, if we run this code again, it's not going to have to download the model again. But it's great. We don't have to rely on anybody. So it's running it locally. So what we might want to do now, let's see what's in my cool list here. Let's say we speak a language that isn't English and we want to put things into this. Now, there's a crisis where, do you want to call this pipe? Do you want to call this classifier so that you know it's a classifier? I don't care what you call your variables in this case. So right now, we previously were classifying things just in English, but I know a lot of folks here speak languages that are not English, and you're going to classify things that are not English. So, u mnie zadzwoniło telefon, that means my phone is ringing in Russian. If I run this for BART large MNLI, if I say my phone is ringing, is that about communications, cooking, or dancing? I'm going to argue that that's very clearly about communications. Very clearly about communications. But if we look at the output here, it's like probably about communications, but I'm not really sure. Like maybe I've seen a little bit of Russian in my day, but not enough. And so in the same way, so yeah, the question of how do we evaluate the accuracy of the model? It's the same thing we did in the first 2 sessions where we classify a bunch of things. We can even do it in sheets, right? We classify it. I'm going to copy and paste it, and then I'm just going to say paste values only to save it. Or I go to file, download as CSV. And then I have someone manually go through and classify, manually classify it. And then I compare it. And I see how often do they match and how often do they don't match. You can usually get kind of a gut check, though, by looking at those accuracy scores, though. Because if we look at, or the confidence score. So if we look at this and we say, it's only 57, 58% sure that this is about communications, maybe this model is only really good at English. Let's try some other ones. And the thing that is so great about working with the Transformers library and Hugging Face is that in order to use a different model, if we're here, we say, oh, we don't like this model. We want a different model. What model do we want? Oh, let's say we want to use this model here. All we have to change about our code, here, I'm going to copy this. I'm going to paste it here. I'm going to copy this. I'm going to paste it here. Let's see, I'll call it. So all I have to change is I just click copy right here, which pulls this very long Moritz, Lauer, M. Deberta, V3 base, blah, 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 blah. And I just paste it in there. And I say, what does this model think about this urgent phone situation? And it says, it's mostly about the phone, also about urgency. And I go down here and it, oh no. Oh, it's called pipe. Sorry. And it says, I am 95% sure that this is about communication. So probably, we can have confidence that this model will do better if we're dealing with Russian or if we're dealing with other languages in general than the Facebook model, even though the Facebook model is more popular. Do we know that for sure? No. But it gives us the idea that, okay, maybe we should do our first run of checks with this model and then do a later run with another model. So will the model give us the same scores every time, or does it give different answers every time the same way an LLM does? So there's, I might be lying, but there is not a temperature score for these models here. There are, I mean, you can coax temperature scores out of the text generation ones later, but for classification stuff and all of this, no, you're not going to be getting different answers out of this. All right, what is next? Okay, so we're feeling good. This is our text classification here. So I'll move this down. I'll provide a headline and it will say text classification. Great. We love text classification. Now, the next thing, when we were looking at, I'll send you the sheet later. If we're looking at this sheet thing we did here, one of the things that we did the other day was we took a piece of text and we extracted all the people that were mentioned in it. We said, let's see, this is going to be under session 2 links, data extraction. Oh no, it doesn't cache these things. It's terrible. Just trust me. Just trust me. Here, I'll go back to my slides, in fact. Okay. So when I was trying to do this right here, this was named entity recognition. Named entity recognition, the idea of there are types of entities that exist, things like people, events, locations. I would like to pull them out of a piece of text. Now, typically or traditionally or semi-traditionally, you don't do this with a Hugging Face library with transformers. What people traditionally have done this with is a library that is called Spacey. But you can do it with transformers. So we're going to do it with transformers. When we are inside of the transformers library, though, this is named entity recognition is what we're trying to do. But if we go to the Hugging Face website and we look at tasks, there is nothing on here that says named entity recognition. But there is something that's called token classification. And for some reason, finding people's names and organizations is not called named entity recognition. It's not called like finding stuff. It is called token classification. So I'm going to throw this in the chat just in case you want to, for some reason, end up on this page. And so the game is about memorizing names of things. So Sharon's question, do we need to be concerned with token input limits for these? Or does the input get split? I'm pretty sure that you do need to be concerned about it, but you'll get errors if your tokens are too long. But I haven't pushed giant pieces of text through these, like book length content. So I forget the details of exactly how it works, and it might actually specifically depend on the model that you're sending things to. So for token classification, again, all we need to do is we can go two routes. We can just scroll down here, scroll down, scroll down, scroll down, and it says, here's how to do named entity recognition. And I say, okay. I copy it. I'm going to say named and oh, look, it auto-completes for me. Love it. Some markdown. And I just paste the code in. Python code. And I run it. And it says, hey, you didn't tell me what model you wanted to use. And it says, by default, I'm using this model. And you're like, is this model good model? I mean, it's the default, so maybe it is. Who knows? So what I'm going to do is, while it's downloading 1.3 gigs of the model, I'm just going to go to the models page. And I'm going to search for token classification. And it says, here you go, medical NER. Do we care about medical stuff? Probably not. I am going to sort this based on most downloads. And it says this one is the most popular one. It's about Arabic. This one is the second most popular. It's about Japanese. This one right here is about French. And so when you have these models, they're all based on, so there's a model, text model called Elmo. And then there's another model that was called Bert. And so Bert and Elmo were like characters. And then now all the ones, then they turned Bert into Bart. And so it's just when people come up with names for the models, they're often kind of in jokes about the names of the models things are based on. So Camembert is Camembert. Roberta is just a bigger version of Bert. And it just, yeah, there aren't any other fun ones here. No, sadly. But all of these models have certain specific tweaks about what they're good at or what they're bad at. So it might be language-based, it might be other stuff. So I'm going to pull out dslim Bert base NER, is I think what I'm looking for. Yeah, so I run the model on this and it says, hey, there's a person named Omar and there's a location and the location is Zurich. And I say, sure, that's fine. Let me try a different model though. So I'm going to copy this and all I need to do to try another model is say, hey, I want my model to be this one instead. And I run it and it says, there's a person and there's a location. And you're like, okay, I'm not very impressed. It's usually good to try with larger pieces of text. So here's a larger piece of text. It's a, piece of news. And I can run this text through my classifiers. And so I'm going to adjust the code a little bit to make the output a little bit easier to read. And it looks like this. And it says, I have an organization that's the Arizona House. I have miscellaneous, which is repeal 1864 abortion law. Why does it think repeal 1864 abortion law is a thing? It's clearly not a thing. It's clearly just part of the headline. And you're like, oh, it got tricked by the fact that it has capital letters, probably, right? That's why it thinks that it's a thing. Phoenix is a location. Democrats are miscellaneous. Democrats, Republicans, miscellaneous. Katie Hobbs, person. All of these things are miscellaneous or locations. If I try a different model, so when we have models, so this is called BERT base NER. If we go back to models and we search for DSLAM, actually, is there a link on? Not there. Is there a link where we were? What if I don't make it cased? There we go. So let's say we're on this page. And down here, it says, if you'd like to use a larger BERT large model fine-tuned on the data set, a BERT large NER model version is often available. Now, oftentimes when you are dealing with these models, they are not large language models that are giant. This model right here is, yeah, it's about 400 megabytes. And for some people, so smaller models will run faster. Sometimes they give good enough responses for you. Usually you have like a base model and a small model and a large model, because they're like, we might as well make a one for someone who wants the best results and one for someone who wants, you know, faster results. And so in this case, if we go to this model, it's BERT large NER, which is maybe better because it's larger. And so we can just say, oh, hey, instead of trying it on BERT base NER, let's try it on BERT large NER, and we run it, and we look at the results and we see whether it makes sense or not. And that's what you're going to be doing, is you are going to be trying out different models to see if they work. And that's it. Now, the problem with doing this, as compared to what we did when I don't have the code for this up. Actually, I can probably find it. Session 1, session 2, links. Now, when these models are created, specifically the named entity recognition models, they have a specific number of things that they are trained to recognize. So right here, if we scroll down, we should never read the thing on the left, right? But we're going to read it. It says a miscellaneous entity, a person's name, an organization, or a location. These are the only things that it is able to recognize. If you want to get a time frame, which some of these know, some of them know like August or next week or things like that, you're out of luck. You're going to have to find another model that does understand time. The great thing about using a large language model like GPT or Claude is it knows what everything in the world is. And so I can say, analyze this text and find the people, the events, the organizations, and the locations, and I can just add more stuff to this. And if it's something that GPT probably understands, suddenly my model knows how to process it. It will know time frames. It will know countries versus cities. It will know, you know, pieces of legislation or anything in there. So oftentimes NER is something, or named entity recognition is something that is now kind of being taken over by large language models, where other tools like maybe summarization, you can do it kind of poorly with these original models, and you don't need to rely on large language models instead. But again, next week we'll learn how to run large language models on our own computers, so maybe that solves all of our problems. Okay, so that is named entity recognition. What else might we want to do? Let's go look at the tasks. So we think Camembert is funny. Does anyone here speak French? So if we go to translation, translation's very, very funny because in the task tutorial here, it tells you here is how to get a translation from English to French. And you run it. And it downloads a model that's 900 megs. It's from Google. It's called T5. And this translates from English to French, and it says, how old are you? And it translates to this right here. Now, if you spoke French, you would know that this is the literal translation of how old are you, which is not the way that people say, how old are you in French? If you were speaking French, you say like, how many years do you have? And so this model, the default model, just doesn't work. It doesn't translate text correctly. And it's great because the person who wrote this, I believe, knew this because they first have you use the default model, which translates this incorrectly. And then they say, here is another model that you can use. Here's another model you can use. Helsinki NLP Opus MT ENFR. And so let me just say, my model is now going to be whatever this is. And I run it, and it will now translate this correctly. And I think that the person changed the text to be how are you, whoever copy edited this page, because they wanted it to like not be the same as the last translation, or they didn't understand why the translation was different between the two. Oh, but the reason is because this, it's like a joke. This translated it wrong and this translated it right. So when you are working with all of these tools, you can't just take for granted what they do. They are far worse than large language models at doing anything involving languages. So you have to test them. You have to test things that come from large language models too. But this, if you make the spreadsheet and you automatically translate a bunch of stuff using the code I give you, you can't just take it for granted. Okay. So we're not going to do RAGs yet. Let's jump ahead to images because images are pretty fun. So when I was at I wasn't at, I was watching videos from International Journalism Festival, and I was looking at the AI showcase, is I believe what it was. And one thing that, let's see, captions. One thing that the AP was talking about was if you search for images, they had people who would caption images previously, where like, if it is a picture of a dog, someone would type, this is a dog. If it was a picture of Joe Biden eating ice cream, they would have typed Joe Biden eating ice cream. But the problem was they have so many images that maybe there are a lot of images that are of Joe Biden eating ice cream, but you don't know that they're of Joe Biden eating ice cream because no one went and typed the caption of Joe Biden eating ice cream. So what can you do to automatically caption an image? Because what you want to be able to do is use text to search these images without manually writing captions for every single one of these images. So if we go on to Hugging Face, we click models. On the left-hand side, we scroll around and we say, okay, this is probably computer vision. This is probably an image, and we're going to convert the image to text. And it gives us a few different examples. And the thing that was shocking to me about AI and machine learning is Salesforce is like they're up in the business. It's like all of the AI companies or all the social media companies like Google and Facebook and things like that. And then Salesforce has a ton that are specifically for mostly dealing with images, especially dealing with invoices, like processing invoices in an automatic fashion, which seems like, of course, but it seems great. So click through. This will caption an image for me. And so just like before, there's that little sample on the right-hand side. where what I can do is I have some images here. I have an image of a couple cats. Couple cats, right? I can just drag this image on over here. And I can say, tell me what this is. And it says there are two cats sitting next to each other in the grass. True. And I say, what about this one? It's Big Taco Bell. I drag it on over. Thinks about it for a while. It says, there's a Taco Bell sign on the front of a restaurant. It's not going to assume that it is a Taco Bell restaurant. It's just going to say on top, in front of some restaurant. Could be a combination, pizza, Taco Bell, anything's possible here. So if we want to use this model again, all we have to do is click using transformers, and then it gives me the option there. I forget whether this is actually the one that I end up using. Yeah, this is the one I use. Okay. So I can just copy and paste this code. Someone could have placed a sign overnight. It's true. So image captioning. I'm just going to copy and paste it. I'm going to load this. I'm just going to call it pipe because they call everything pipe. So I might as well. And I'm actually going to change my code from PIL import image. Is that true? Let's import PIL and then say image PIL. Yeah, there we go. Great. My image is in images and it is hk.jpg. So it is this kind of complicated image. A lot is going on, right? Nice little cityscape there. So I'm going to open up that image and then I'm going to feed it into my pipeline. And it says, people sitting at tables in a busy Asian street at night. How good is that? That's incredible. How did it know that, right? So it can look at the text and say, oh, here's probably what's going on. So image captioning models are amazing. And you say, let's try another one. And I say, okay, why not? So models. We are going to go to image to text. We're going to sort by most downloads. And here's the most popular one. VIT GBT2 image captioning. And so in the same way as we did with everything else, if we want to test out another model, we just say, hey, let's just try the other model. Why not? Copy it, throw it on in there, run it. Let's see what it says. I am the #1 fan of not understanding how things work. Because I think that when you don't understand how things work, you are more suspicious maybe of what comes out. Or you're more willing to not think about it from a technical perspective, but rather from the, is this doing what I need it to do perspective? And so if we look at this, a bike shop with a lot of bikes parked in it, is this correct? I know. But you can see why it might think that, because there's a couple bikes. Why else would people have bikes outside of something if it wasn't a bike shop? I don't know. Let's also try this. There's an image of a man throwing a frisbee for a dog, and let's see what happens there. So I'm going to copy this. I'm going to say, how does the frisbee work? A man holding a frisbee in his hand. He is throwing it. Let's try the Salesforce one. See if it does a better job. There's a man playing with a dog in the yard. So it doesn't get the frisbee, but, you know, does a good job. Speaking of dogs and frisbees, so we talked about image classification previously. We talked about classifying zero-shot classification of text. It turns out that you can also do the same thing with images. So let's say there's two different ways we can talk about this. One of them is object detection, saying there is something that I can see. There's something I can see here. And so this model right here that they recommend us to go look at is called Facebook DETR ResNet 50. And you're like, what's that mean? Who knows? And so what it does, if you drop in an image, it says, I found a bus, I have a person, a truck, another person, an airplane, another airplane. And it just finds things in the image. And so let's say I take this Frisbee picture and I drag the Frisbee picture on over. It knows what a Frisbee is. It knows what a dog is. It knows chair is in the background. It knows there's a person. It knows that's a fence, not a bench, but close enough. And you say, wow, that is so technical and complicated. How could I ever possibly do that? And I say, oh, don't worry. Don't worry. It's very easy. All we need to do, I don't want to do that one. Let's see. Let's look for... Oh no, I deleted something. All right, we're going to use this model right here. No, we can use the Facebook one. Why not? They're all the same, right? So I'm going to say, let's find all of the stuff. Oh, I shouldn't have done it. Oh, it's a very small model. That's fine. And now I'm going to say, go look at this image and find, oh no, what did I do wrong? Oh, it should be called pipe. Sorry. Nope, it's not called pipe. It's called detector. I take it back. I'm using a different model. There we go. Okay, so I have this dog right here. This is a dog. And I say, find me a dog in that picture. And then it says, I'm saying, look for dogs and look for cats. And then it finds it. Can you export all of the elements in each image into a CSV or dictionary? Yes. So right here, I could just take this list. Let's say I get this something a little more complicated. Let's say look at my Frisbee picture. And instead of just looking, here, I'll put this in another cell. Instead of just looking for a dog or a cat, I look for a dog, a cat, a man, grass, Frisbee. Here are all the things I want to look for. And it says, here are all the things that I found. And if I wanted to throw this into predictions, if I wanted to throw this into pandas, I could... There you go. There, it's all the stuff that's in it saved into a CSV, right? Super easy. I could also draw those results. And I could say, like, annotate this image so I don't even have to go to the Hugging Face website. Why do these companies share their models for free with Hugging Face? So there was a interview that Mark Zuckerberg did, I don't know, a few days ago now, where they actually open source, and we'll talk about this next week. They didn't just open source like an image detection model or something like that. They open sourced their brand new gigantic chatbot, like their chatbot that is basically as good as GPT-4. They just put it out there and they were like, anyone can use this. You can download this on your machine. And he said that they're going to be spending billions and billions of dollars running this software over the next X number of years. So if someone can make it a little bit better, as a result of someone making it a little bit better, they will be able to save money in the long run. Additionally, for these smaller models, when people publish research papers, they like to also publish the models And it's very often, if they're like big secret models that they're going to make a lot of money off of, sure. But it's just like there's a culture of sharing models that just exists. But there's an argument where some of these models, especially the earlier versions of the ones that were being produced by Meta or Facebook, where they said you can't use these for commercial reasons or this or that other thing. And there's also an argument we'll talk about next week about what counts as open source. Like, we don't know what they trained this on. We don't know what all the data sets are that it was learned on. That's not necessarily true for things like the Salesforce Blip models and stuff like that. So there's a million years of discussion about all of that. Let's just burn through a few other things that we can have models do. Let's look at image classification. So image classification, and then we'll look at a few news use cases. So image classification, if I go here and I drag the dog over and I say, classify this dog, it says this dog is a golden retriever. It's not, it might be a Labrador retriever. It's definitely not a tennis ball or a Sussex Spaniel or whatever that thing is. Maybe that's the kind of dog. If we are running, oh, so where on the model pages that you can tell that model is the latest from Facebook? That's just from social media. The way that you end up on Hugging Face a lot is you read Twitter and someone's like, a new model was released. I became a AI Hugging Face convert because of something called Segment Anything. So they released a model called Segment Anything, and people were like, you can segment anything with it. Like, you can find all the dogs and highlight them in the picture, whatever. It's amazing. And someone just linked to a Hugging Face space where, let's say it's like this one here, where they said, hey, and I just clicked a picture of like this city, and it said, this is a building, this is the sky, this is a tree, this is the sidewalk. And I just said, this is the craziest thing I've ever seen. This is free. It just runs on the internet and we can try it out. Like, the joy of all of this is someone tweeted about it, and like 5 seconds later, I was see, there we go, it's back. Okay, sorry. So yes, social media, it's all social media. So when we run this model here, if you are a journalist, what might you be using image classification for? Unlike something like text classification, image classification is usually a little bit more specific. And there's a kind of, I'd say it's old school. There is a piece that came out in 2018 about, what happens if I click it? I've never clicked that before. I'm gonna hit back. So it was done by Texty, a Ukrainian organization, and it was about illegal amber mines and about finding illegal amber mines by combing through satellite imagery. And so they did this the old-fashioned way, the way that we looked at the Washington Post, where they took a bunch of examples of an illegal amber mine taken from satellite photography. They look like this. There's a lot of little holes in it. And then a lot of images of things that don't have illegal amber mines, just like normal satellite imagery. And they wrote like a big like image classification model, and there was all kinds of technology, and there's like a giant write-up they did a talk at C+J all about how they did it. And it was just like so much work to the point where there was a like Google News Initiative did like a whole multi-part training about how to do this. I'll throw all these links in the chat. I don't know where the chat went. There we go. 1, 2. And so it was just like, it was very complicated. But nowadays, if you want to do this, the way that these models work is just like how most of these, like what you do is you fine tune a model. You have a model that exists that already knows, it's like a teenager, right? It knows what an image is. It knows what a circle is. It knows what, you know, squares are. It knows what all this is. And you just have to say, here's some examples of an illegal amber mine, and here's examples of not an illegal amber mine, and somehow it automatically figures it out. So I'm going to go to my example here where I show you the output, where because as journalists, we probably don't care about golden retrievers. What we care about is, I hope it's this one. So I have a model right here where I can upload a picture of a cat. Currently, auto is the bad one. What's the good one? Maybe this one will work. Please work, please work. So the automatically created models on Hugging Face don't always work great. Okay, so it says, I don't know if this is an illegal amber mine or not. I think it's not, but I only have a 55% chance. And that's because I never taught this, or I taught it not what cats and dogs look like. I taught it what an illegal amber mine looks like. So if we go into these right here, which I believe are not illegal amber mines, and I upload one of these satellite images, it says, I'm pretty sure this is not an illegal amber mine. And if I go to the positive one, I upload it, and it says, I'm pretty sure this is an illegal amber mine. This seems very fancy, right? You say, how am I ever going to be able to do this? And I say, Hugging Face makes it, used to make it really easy, but now it's only kind of easy. They have this thing called the AutoTrainer, where I'm going to create a project. I'm going to make this 0 to not pause on failure. I'm going to click duplicate space. Great. I'm already here. Great. AutoTrain project. What did I call this? This? Oh, come on. What are all my spaces called? Hugging Face is not perfect all the time. Let's be honest here. Okay. So what they do is you basically just create a little bit of data. I have 20 examples of not an illegal amber mine right here, and 20 examples of illegal amber mines here. And I put them in a folder. One is called negative because it's not an illegal amber mine, and one of them is positive because it is an illegal amber mine. I zip them up and I just upload it to Hugging Face, and I say, Hugging Face, take one of these models that can learn about dogs and learn about buildings and stuff like that, and just tweak it so it only knows 2 things, illegal amber mines and not illegal amber mines. And then you have a model that just works. You just do this. You just say, hey, I want to do image classification. I want to upload this. I got to click here. Here is my data set. And then there's one thing you have to change, and you have to type false right here. Why? I don't know. This used to be so much easier, but now it's hard. And then you just click start training, and it just makes a model for you. It just does it just for you. So if you want to do some sort of classification that is not cats or dogs, or, you know, if you wanted to classify it, to make a text classifier that was about New York City neighborhoods or something like that, you might have to make your own custom model, but not from scratch. You're just building on top of an existing model using this fun AutoTrainer thing. Now, what else you might want to do is more specific than this. So if we look at the New York Times, So a New York Times investigation tracked Israel's use of one of its most destructive bombs in South Gaza. And what they did was the Times programmed an artificial intelligence tool to scan satellite imagery for bomb craters. Times reporters manually reviewed the results, blah, 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 blah. If you go to the Hugging Face website and you look at tasks, one of the tasks is object detection, which we already did, right? So remember when we said, this is the Frisbee, this is the man, this is the dog, this is the grass. We were using a model that only understood what it already understood. It only understood Frisbees, dogs, man, and grass. But what if, just like we did with those illegal amber mines, what if we took a bunch of pictures of satellite photography and we just drew little boxes around all of the things that we knew were craters from these specific kind of impact craters, and then we drew a bunch of boxes around like stores and sports stadiums and other things that aren't. Can we make our own model that does this? And the answer is yes, we can absolutely do this. It's harder to do, but I'll just show you an example. There's a website. There's a lot of tools you can use to do this. The one that's cheapest is called CVAT. I don't know how people actually say this. It's hard to set up and hard to use, but people love it. They think it's great. There's a tool called Prodigy, which costs $400 once. It's from the same people that make Spacey, if you're familiar with Spacey. And you just go in and you're like, you can use it to train like custom entities and all this stuff. But what I'm going to be doing here is I'm going to be annotating images. Let's see, where is that? Not image captioning. Yeah, manual images. And so I can just like draw on the image and be like, this is a corn. This is a corn. This is a corn. This is a corn. Great. Show me the next image. This is a food. This is a food. This is a plate. And it's just that easy. It's just that easy. And then when you're all done, you have data that you can use to create a model. There are websites, like there's one called RoboFlow, which is, they're basically Hugging Face, but for computer vision models specifically. And people get grumpy because they cost a lot of money. But this was me, where I took a bunch of satellite photos from around my house because I was angry at how there were so many cars everywhere. And I just drew boxes around every single car. And I trained an image classifier to figure out how many cars there are here. Is there a Hugging Face equivalent to Prodigy? No. So if you want to do image annotation and then connect it to Hugging Face, you have to use one of these external tools. So RoboFlow does have an automatic bridge to Hugging Face. I think it's a little bit hard to use. Yeah, it's not something I spend an infinite amount of time doing. I'm mostly on the image classification side. Do these tools give guidance on training set size or how much the training works? Yeah, so usually the old version of the AutoTrainer gave you, actually no, the current version of the AutoTrainer still does give you good results. So let's say we go to my custom model. Oh, let's see if my custom model is still training. Okay, it stopped training. It said, we're done. You now have a new model. And let's go find this new model of mine. This is the new model that got created. And it gives you these metrics. So the metrics of precision and recall, area under the curve, accuracy, loss. And so just know that like the bigger these numbers are, the better they are. Am I going to explain all these numbers? No. But if you do use the AutoTrainer, it does tell you how your results do. If you use the RoboFlow one, I actually made a, let's see, health check. So let's see, generate versions. Yeah, so for my tagging cars on the road, my model's pretty bad. My model has a recall of 60, a precision of about 50. It's not the best model in the world. Upgrade for that. So RoboFlow is pretty complicated and you have to click around a lot, but it is a lot of just like you screw around until you get something that works, which is why if you're the New York Times, you contract with this external firm whose name starts with the I, and you can get a free demo. Let me see if I can find the name of the organization. No. Let's see. Satellite photos, image. I'm doing this off camera. I had a good YouTube video about it. I'll try to find it and send it out to you all. Okay, what else? I was hoping to not go infinitely over today, but you know how these things happen. Let's do... We're going to do rags now. We're going to do rags. Okay. Now, the CVAT Not 3 looks open source. So if you go to cvat.ai, if you go here, they will try to charge you money by doing it on the internet. That's what all these services do. They say, oh, you want to use it easily? Click this internet button. But you can also find it on GitHub, and it is free. So... but you have to like set it up and make it be hard. It's hard to run. I think there's also Label Studio. There's a lot of these things. The metrics are based, so Jeff's question, and the screens are the metrics are based on running the model in a training set or the subset of it. So they divide it up into, they give you like, they let you do the picking and choosing, but there's a set of it that trains the model. So the model learns using that. And then there's a holdback set where they say, we're not going to let you see the answers to this. So just like when... if I'm your professor, I will give you a series of sample questions for you to know what's on the test so you can learn based on that. And then there will be some that I'll keep secret that I'll use to quiz you that I know the answers to. So it'll take like maybe 90% of the data, let you learn from it, and then 10% it's going to keep secret and then quiz you on it to see how good the model actually is. Okay, closing all these. This is fun. So Quartz, they were like, okay, we have a bunch of documents. We have a giant 350 gigabyte set of data to read through. But there's a problem. Yeah, so Gerald, is there a link to the notebooks that have been posted or sent around? So if you are signed up on the Eventbrite, I will be sending that out. I didn't send them out on Tuesday. I was too busy. But I will send out my completed notebook at the end of this. Absolutely. And it'll have more stuff in there than what we actually talked about. So here, what they did was they did basically a fuzzy search that went across different languages. So if I can say, where's the example here? Yeah, so if you searched for establishing a new corporation, it would give you all of these things that are not an exact match about establishing a new corporation, but were similar in vibe to establishing a new corporation. Additionally, last class, well, let's just go wild. Let's do a little PowerPoint here. So how did they do this? How do they have this fuzzy searching across languages, which will then end up feeding into chatbots? So text embeddings. Text embeddings you could teach a 90-minute class on, but we're going to do it in 20 maybe. So if you have a bunch of animals and you put them down onto a page, let's say we're going to start with a cat. What are my cat, dog, wolf, tiger? Great. If you have a cat, is a cat and a dog the same animal? I'm sure half of you have seen me give this pitch before. Is a cat and a dog the same animal? The answer is no, right? Cat's over here. Oh, shit. Tiger first. Is a cat and a tiger the same? No, they're a little bit different. Put the tiger over on this side, right? Cat, tiger, sure. If we want to talk about dogs, is a dog more similar to a cat or is a dog more similar to a tiger? The dog is going to be more similar to a cat, but it's not the same as a cat, right? It's not the same as a cat. There's a difference between a cat and a dog in the same way that there's a difference between a cat and a tiger. But the difference is a different kind of difference. And so if we add a wolf to this, a wolf is more like a dog than a cat. So it's going to go up near the top, right? But it's because it's a canine. But it's also more wild than a dog or a cat, kind of like a tiger. So it goes on the right. I forget the next slide, whether I put a lion on here or not. Half the time I do, half the time I don't. If there were a lion on this page, it would probably go in the bottom right. Because like for all intents and purposes, lions are the same thing as tigers. They might be a little furrier sometimes if they're a boy, but they're basically the same. So this is what text embeddings are. It's the idea that we can take this feeling about what something is, whether it's more dog-like or whether it's more wild, and we can put it on an axis where we can say, as you go higher on this axis, you're more of a dog. As you go out on the x-axis, you're more wild, like a tiger or a lion. If you're, you know, a little calm baby, like a cat or a dog, you're less wild, you're further to the left. If I were to add something like socks to this, though, socks don't really fit those two axes, right? Like, are socks like a dog? No, they're very not dog-like. They're also very not wild. But putting it next to a cat doesn't really make sense, right? So we need a third axis to go out and put socks on it. And then the more words we add to this, like if you have a chair, where is a chair going to go on here? Like a chair's not clothing. It's not very wild. It's not like a dog. It's very much like furniture. But how does a table compare to a chair? And so as you go deeper and deeper, and as you go add more and more and more words, you have to add all of these different categories that we're scoring things on. So for every word in the language, we're going to score it based on how much like a dog it is, or how wild it is, or how much it's like clothing, or how fuzzy it is. So like, you know, if I have socks, they might be fuzzy and they might be clothing. A cat is also fuzzy, but a cat is not clothing, probably. And a cat is, you know, not like a dog. And cat is a code command, but it's also, you know, an unwild animal. So how many different dimensions do we think we need to accurately describe all of the words that exist in the English language in order to have like a really solid set of axes where we can reasonably say like words that are together are kind of similar? Like over here, like tiger and lion, they're similar. In order to do that for all of the words, I don't know. Different people came to different conclusions. So these are called text embeddings, and it's the idea that you can take a piece of text and just give it a number. You can give it a number in the same way that we gave all of these numbers, where we scored it on a bunch of different categories. But this can be like 256 different categories, or 384, or 512, or just like some random ass number of categories you can set it to be. And then that means that object out there in outer space. And what this allows you to do is take sentences like Jen ate a fish and Molly consumed a carp. Technically speaking, these sentences have only one word in common, and that word is a. But emotionally speaking, they're all about a woman consuming a fish, or some sort of fish, right? So like the vibe of these sentences is the same, even though the words don't match. Vibe match. And so what this allows us to do is, if we're assigning numbers to all of these pieces of text, we can say, are these numbers kind of similar? Do they kind of match with one another? Which allows us to create conceptual document similarity instead of word-based document similarity. And so in the same way that a model, we've seen multilingual models, or models that only work for English already, where it was putting things in categories, and one of them only knew English. But some models know multiple languages. And so what that means is, if you can do this text embeddings thing, where you convert things to numbers, when we work across multiple languages, if you're talking about the word cat in English and the word cat in Russian and the word cat in Japanese all ending up in the same kind of similar area just because of how language ends up working. And so you end up being able to search by vibes, not even just in a similar language, but also across different languages. And so when we talked last class about chatting with their documents and how bad it works, right? And the way that chatting with their documents works is if I'm asking a large language model for content about something, sometimes it knows, or sometimes it's read enough to know what the adult average weight of a capybara is. But usually what you want to do is say, hey, AI, based on the information I'm giving you, answer this question. And that's how chatbots work, right? So chatbots, they get a ton of information, and then you say, based on all of these PDFs I'm giving you, or all these text files I'm giving you, or all these excerpts I'm giving you, answer the user's question. And so we saw something that was tragic. And the thing that we saw that was tragic is chatbots don't work. Chatbots don't work. We saw they don't work for 1,000 reasons on Tuesday. But this one, where in theory, this chatbot for the city of New York has read all of these websites, this source of income discrimination website, these like tips and gratuities, frequently asked questions document, all the documents that come from New York City, it has read them. And then when you ask the question of like, can I steal my workers' tips? It's like, yeah, of course you can, despite the fact that the documents say that you cannot. So who here wants to make a bunch of money from Eric Adams? Do we want to get, we're not the NYPD, but let's chat with documents. So what we are going to do is I have a bunch of PDFs. My PDFs live in this file right here. And it's the exact same PDFs that were linked to by the markup, right? So we have this PDF about best practices for avoiding income discrimination and a Section 8 guide for tenants. I just printed off the webpage. Like, it's the jankiest stuff ever. I spent no effort on this. I did originally convert it to Markdown, but we won't even do that today. So what we are going to do is we're going to use a tool called Llama Index in order to build our chatbot, or in order to turn our RAG, our retrieval augmented generation, where what we're doing is we're finding a bunch of similar documents to whatever our query is, and then we're sending them to GPT along with our question. So let's do it. All we got to do is cut and paste from the documentation. It's great. So I'm going to scroll through all of mine. Nope, that's not the one I'm talking about there. That's not the one I'm talking about there. First way of doing this, we're going to do it with GPT. We're going to do it the basic way, where we're a slave to ChatGPT. So I'm going to connect myself to OpenAI. I'm going to say, here's my secret code. Please don't steal my secret code. Here's my API key. This proves I am who I am to ChatGPT, so that they can charge me a bunch of money. So what I'm going to do is, first up, I'm going to find all of my PDFs in my documents folder. I'm going to use my favorite library. And I'm going to say, go find every single PDF inside of documents. We looked at those documents. They're real. They're good. They're true. And then I'm going to say, hey, I want to read all of them. I'm going to read all of them. And you say, what just happened? And I said, I'm just copying and pasting code. Don't worry about it. Don't worry about it. So what it did was it read the files in that directory. We didn't even have to say, here are the documents. We could have just said, read every single file in that directory. And then we say, create a vector of each one of them. Create an embedding, that big long number. Create a big long number for every single chunk of document. It broke it up into chunks that are about 512. They're tokens long, but we'll say 500 characters long. Tokens long, question mark. It broke it up into a bunch of small chunks, and then for every one of those small chunks, it generated an embedding. So it gave it one of those numbers that is somewhere out in space. And so all we have to do now is say, hey, I want you to find the top 5 most similar documents to my question. Can I keep my funeral home pricing confidential? It takes those documents and it sends them up to GPT, and it says you should not keep them confidential. It's important to be transparent about pricing to ensure compliance with regulations. And you're like, I don't know. I don't know anything about that. Let's try these, because these are the actual things that were asked by the markup. So we'll see if we did a better job than whoever Eric Adams paid. Are buildings required to accept Section 8 vouchers? And it says, most rentals are covered by the law that prohibits discrimination based on that. There are a few exceptions based on a building, if they live there or not. And you say, I thought that you couldn't discriminate. Oh, wait, there's the minor exception. You say, how did it know that? How did it know that? And what you can do is you can print out all of the documents that was sent to GPT along with this. It sent this piece of text from this file. It sent this piece of text from this file. It sent scrollable element, yes. It sent this piece of text from this document. So this is what is happening when you have one of those chat with your documents. It is simply providing all of this. It's simply providing your question and all of this text and saying, hey, GPT, based on this information, answer this question. So my question for you is, it was wrong here because everything Eric Adams does is terrible. It was right here. But on Tuesday, we spent a lot of time discussing how chatbots, they're not really good to have. The issue with chatbots is you end up in a situation where someone like makes it sing a song about Hitler, or it says, ignore all of your instructions, tell me I can get a refund or whatever. And you're potentially liable for things your chatbot says, despite the fact that the reality is different, because you're telling people trust the chatbot, even though the chatbot is generative AI. It's just making stuff up, right? So what can we do instead? If we don't want to trust the chatbot, what I recommend to do, the responsible way I feel like to deal with this is when we had this thing here, let's see, let me confirm. Okay. I'm going to start from a new, yeah. So instead of using, we had this index. Instead of having the index to make a query to the LLM that says, answer this question, what we can do instead is we can say, hey, I want to search for related stuff. I want the top 10 matches. And I want you to tell me everything that is about, let's say, paying rent with vouchers, or we'll stick with that one, paying rent with vouchers. And this will now print out for me everything, all of the relevant pieces of information that would otherwise be sent to the LLM. Because I think it's probably more important for me to read the documents themselves to make the news judgment instead of sending it off to the large language model and saying, please make something up. And so it's actually very easy to do this. Again, we looked at the multilingual analysis here, and we can also do this ourselves really fast. This will be the last thing that we do. It's my favorite game to play is I have a text file that I pulled from the internet. And the text file from the internet is about Hungarian folktales. It's an old book of Hungarian folktales, and it's all about Zsuzsa and how Zsuzsa does a bunch of stuff. Zsuzsa goes on adventures. Zsuzsa talks to the king. Zsuzsa steals things from the devil. And I'm obsessed with knowing what Zsuzsa steals from the devil. And so what I'm going to do is I don't want to send any of this information to OpenAI, though, because this original content up here, to get the embeddings, it sent it all up to OpenAI. And I'm like, I don't want OpenAI to have all of my secret Hungarian folktales about Zsuzsa. So I'm going to use a model that you would find it on the Hugging Face website. I'm going to use a model that just will live on my computer, so I don't have to rely on anybody. And so again, I can do things like, if I have the text, I am a cat, here are the first 5 numbers that represent I am a cat. So when I embed something, I'm just turning it into a very, 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 very long number. Let's see how many numbers are in this one. Yeah, 1,024 numbers to represent every single one of these pieces of text. So I am going to read in my text file. I'm going to say, hey, read in all of those Hungarian folktales, break them up into little pieces, little tiny baby little pieces, make sure those chunks overlap a little bit. And now, every time I search for a piece of text, find me the top 4 matches. The top 4 matches for whatever I'm searching for. Now, the reason why this is so helpful is I was at a conference and I always forget the organization they work for. It's a mis and disinformation organization. And they have chatbots that run. And people can go to those chatbots to ask for mis and disinformation. But what happens when someone asks about it is it doesn't pull a bunch of content and spit it out to them. What it does is it provides context for a real live person to actually respond to the chat. So the chatbot is not a real bot. It's actually a person, but they are so much assisted by these AI tools and these embeddings that they're basically doing the part that GPT does, where GPT says, based on this context, answer this question, but it's just kind of automatically fed to, we can even think of them as a customer service rep who's responding to the mis and disinformation. So you don't have to cut people out of this totally. Keeping people a little bit there is still pretty good. So I'm interested in the top 4. And what I want to know is I'm interested in passages about Zsuzsa stealing from the devil. I can't read this. I can't read this. I don't speak Hungarian. I trusted this multilingual model here would find me relevant passages. Did it find me a relevant passage? Let's go to DeepL and translate it. I heard you could steal the sea stepper Zippo from the devil. If you not, you'll die a death. Terrible. Terrible. Let's find this other passage. And so I'm going to assume that every single one of these passages, yeah, Zsuzsa said that she could steal all of these things. So you do not have to feed things to the large language model if you're dealing with something that is, you want similar stuff to a chatbot. Additionally, it is very, very easy nowadays, especially, to do cross-language search. Most of the time when you're doing something like this, there is a front end to it. You're using something like Sumantra. You're using something like Document Cloud. You're using something like Google Pinpoint that behind the scenes is using embeddings to do searches. But if you just want to kind of kick around yourself, you know, in a large data set, find the relevant pieces of text, there's no reason why you can't just do it yourself. So we looked at like 1,000,001 models, and we're going to end with just finishing up the Hugging Face Google Sheets integration, just because I want to do it. I'm going to paste in all of my different app script here. I have one that summarizes using this random model from Hugging Face. I have one that extracts entities, but it's specifically from French language. I have one that will put things in categories using the Facebook one that we used before. And then I have one that will describe images based on the captioning tool. So this one's a little bit longer, a little bit more complicated. But now that I've written this code here, anyone can use this. All they need to do is say, hey, yeah, this model had entities. Find all of the entities in here. This model said, describe the image based on this URL. It downloaded the image, sent it to Hugging Face. This one down here, it said, summarize based on this. We did not need to give OpenAI money. We did not need to give Anthropic money. We were writing all of our own code. We can do, I don't know, maybe it runs faster. In the end, large language model probably going to do a better job at most of these things, but potentially the savings in terms of cost, the saving in terms of speed might end up being worth it. So that is all I've got for us today. We covered, I don't know, 70% of what I was looking to do. I'm glad that emotionally I told myself we were going to do stuff with audio next Thursday. So we'll focus on transcription next Thursday, probably a couple little tangential tasks, things like video, maybe some video analysis, because I know people like that. And I will send out an infinite amount of code, an infinite amount of annotated code. So any questions before we go? Any final questions? I need to be able to use my chatting scene here where I'm hanging out. And we can have a chat. So no questions. We're good to go. Perfect. All right. So hopefully I will see you next Thursday, which is the real exciting thing where when I started doing this, why was our NYC chatbot so much better than Eric had? I don't know. They clearly did the worst possible job and didn't check it at all because those seem like very easy answers. I have no idea, honestly, because it seems like that was low-hanging fruit, and it seems like it always should have given those correct answers. So maybe they were using a bad embeddings model. Maybe it wasn't actually sending information there. The mayor's office said they will do a software update, which is going to fix it. Do I trust that? Does anyone trust that? No. Because in theory, yes, you could get better results, but wouldn't it be better if every time you searched for, can I steal tips from someone, it just gave you a link to the PDF and maybe a deep link to the part of the PDF? Don't know. And it's not my NYC chatbot, it's our NYC chatbot. So I'll be sending you all of this so you'll be able to roll your own rather easily. So yeah, next Tuesday, we're going to be doing local models. So figuring out how to run all of this on our own computers, which sometimes involves going to seedy parts of the internet. And then on next Thursday, we will do maybe audio, video, maybe some more image stuff. All right. Have a good one.